Well, and that's what having one of these good for. Making people break their back so you don't have to.
Well, it's a trade-off. Everybody brings resources to the table. Money is a resource. Functional spines are a resource, and one's not more valuable than the other. Just it's what you can bring to the table.
I really want to see this.
Somewhere I have a video of us when Awesome Fat first started, and we had the original Fat Cave in the basement of my house, and we worked out of there. We have a video somewhere of us getting this like old style Pepsi machine down into my basement through, because we have a stairwell where you go down, then you turn, and you turn again. And this is a really old Pepsi machine that, like, when they used to make the bottom of it completely out of lead, I think the thing weighed like 1,400 pounds.
Oh.
It was ridiculous. Hey, you pushed on it the other day, right? The Pepsi machine in my basement?
Yeah.
You could barely budge the thing when it's down there. So it took like 8 guys to try to control that weight down there. We had like tow ropes attached to people and stuff like that. That was entertaining. Yeah, so that's getting sold with the house. Because gravity helped us get it down there. It's not. Actually, it might actually be easier to get back up if you put it like on a
crane?
No, not a crane. What are the dolly thing? The thing I have in the garage. What's that called?
Dolly.
Is that called a dolly? Is it?
Would it fit on the dolly?
Well, you just have to get one edge on it, and then you can pull it up one stair at a time. So it actually might be easier to bring it up on its own.
You can even get specialized dollies for going upstairs.
Really?
Yeah, you have to have a strap on that for sure.
Whoever invents this is a great idea. So, we're thinking about this. This is recorded, so this is a crazy great idea. Wouldn't it be cool if we had teleportation, right? But teleportation is going to be problematic because we're not going to want to test that on people because we're going to be afraid it won't put them back together.
I'll scramble my molecules for science.
Yeah, I mean, it won't. That's going to be concerning, right? But what if you could like beam things like furniture and stuff like that, from out in the driveway down into a basement? That seems like it would be like a legit application, right? That's a $1 billion idea.
More than that.
Yeah, probably. Moving company, they just do a staging area out in your yard. Just beam everything to your new house. Man.
Less pollution.
Yeah, well, how do we know how much pollution the
transport.
For every single time we transport something, a kitten might die. We don't know.
The price you gotta pay.
What's up?
Just the price you gotta pay.
Yeah. It's a good thing that Gracie's immortal, though, so we're good there. Yeah, last night in the middle of the night, Gracie started levitating my massage chair. It's funny. Okay, questions about the midterm before I go on? Want me to recover anything? We talked about it on Monday, right?
Yeah. And we have a study sheet.
You have a study sheet, but I said if you had any additional questions, I'd be happy to answer them today. Otherwise, I'm just going to keep trucking. So no questions. We're good. Keep trucking. Perfect. All right. Let's get to the next interesting thing. I really want to get past this garbage. Are we almost done here? Okay. I feel like we should already be writing operating system programs in here, don't you? We're not writing enough software in this class. Maybe. Right?
Should we make them cry?
Huh?
Should we make them cry?
Why?
Operating system.
That's all hard programs are made of easy parts. It's just going to be loops and all that same old crap. Okay. So this is kind of the secondary tier. We started talking about this the other day. Initially, we talked about MS-DOS versus BSD in terms of their memory model, where MS-DOS loads, your single user program into memory and then your operating system is running there. Well, now we have the actual structure of the operating systems, and this is really dealing with the evolution of not just operating systems, but the evolution of programming. You know, in the early days of programming, we would have what I always refer to as the monolithic main. So all programs begin and end with main, and what you would end up doing is just throw everything in main. So, you know, yeah, it would begin, yeah, it would end in main, but in between there was 4 million lines of code. That's not what our programs look like today, right? Typically, we try to make main as concise as possible. Main kind of gets the ball rolling, but all of the other pieces of your application are encapsulated in various modules, where there is plenty of code in there, but main itself looks very algorithmic. Do this, then this, then this, then this. And the details are hidden within that. Make sense? So operating systems kind of evolved in a similar way. So MS-DOS written to provide the most functionality in the least space, so it wasn't really divided into multiple modules. So when they distributed it, they didn't have to distribute it as a zillion different files. So basically they're saying it wasn't really well structured. Part of that was they bought it from a hobbyist. So they bought this operating system from a guy who just, as a hobbyist, wrote an operating system because he thought it was going to be cool. It'd be interesting to hear the story from that guy, like 20 years later. Like the dude who sold DOS to Bill Gates.
How much did you sell it for?
Huh? Sold it for, I think it was $50,000. Where, I mean, if you're a...
I thought it was a good idea at the time.
If you're, well, I mean, it probably still was a good idea. I mean, if you were a computer electronics guy running a shop and you had a hobby program you wrote and somebody walks in and offers you 50 grand for it today, you say yes. Because, you know, he probably wasn't going to do anything real with it. So it took Microsoft actually doing something with it. You know, I sit around and I write iPhone programs all the time. If somebody walked into the cafeteria at Concordia, I'm writing a program and say, oh, I think that's a good idea. Here's 50 grand for that. Here you go. You start working on one of my other ideas. Could I have made more than 50 grand off it? Maybe. But that would have taken a lot of work. Take the 50 grand and go. You know, when I was talking about that this morning at one of my meetings, it's really something how business has evolved. My brother is in real estate. And what he does now is he goes to a lot of the sheriff sales where they're selling, like auctioning off houses cheaply. So he goes there and tries to buy a house and he sells it to rehabbers, people who want to fix the house up and then sell it for retail. So my brother tries to buy super cheap, then sells it cheap, making his little money in the middle. Well, I guess this has become kind of a corporate thing now, where a lot of kind of heavy money-backed businesses are sending people out to buy these houses. Half my brother's income now is from showing up to these sheriff sales. Those other guys know that he has money to make the bids, so they go and pay him off to not bid. He shows up, goes and collects his bribes, and goes to lunch. It's like a great gig, isn't it? You don't even have to deal with trying to sell the house then. It's like, oh, you'll give me 10 grand not to bid? Cool. So, yeah, it becomes, and the reality is probably the other place is, it's probably financially smart for them. Because they're probably losing less by doing that than if the price had bid up. Oh, very interesting. So, yeah, but it would be interesting to hear that guy's story 20 years later, see him interviewed, you know, like, so you're the guy who sold DOS. What do you think? How do you like your what they've done with your program? Guy's living in a van down by the river. He wasn't very responsible with it. He got a van, lives by the river, and has a life-size T-Rex skeleton or something.
He probably has a non-compete and non-disclose agreement.
They probably didn't even exist then. I don't know. That was kind of before we were as much of a litigious community. Now people get sued for everything, right? I'm surprised you don't have to sign a contract order at McDonald's. Would you see that thing I posted about McDonald's is going to have an open answer, open question type of thing where you can ask them anything about their menu and they'll do full disclosure, like what's in a Big Mac and stuff like that? Like how is their meat actually made? Apparently they're not selling enough of their crap, so they're going to tell you what the crap is.
Isn't that probably hurt them though?
Huh?
You find out what's in the crap.
I don't think anybody who goes to McDonald's starts off by assuming, oh, this is really high grade, super healthy food. In fact, they're probably hoping it's heavily, heavily processed so the pesticides are gone. I mean, same thing with, you guys probably use substantially better ingredients at Little Caesars, but, nobody who goes to Little Caesars is going there because they're on a diet, right? They're going there because it's inexpensive and won't kill them today. I live in the now. What's up?
Clearly.
You're calling me fat?
Yes.
This does not bode well for his midterm, although he is helping move tonight, so I have to temporarily be nice. All right, so this is kind of a simple structured, but all this was in a monolithic main type of thing, or at least most of this. So MS-DOS was a very simple, hard to follow program because it was, by our standards, a large program. The stuff we've written in here, the scariest thing is what, a couple hundred lines of code that we've written? So, DOS was more than a couple hundred lines of code. So a layered approach, operating systems are divided into a number of layers, so levels, each built on top of lower layers, and things kind of pass through those. So almost think of it like a filter. So this is the kind of the Unix thing. I know we looked at this before, so we can kind of see the spill-through effect where we have a couple of layers of system call-y type stuff. So our user applications talk to the operating system through system calls, which talk to the hardware through kernel interface. So kind of a second level of system calls, if you will. Okay, so Unix, modern operating system, but more of a server class operating system, never really took off for end users. I know a couple of you have used Linux in here, but it's more of a hobbyist thing. What's the biggest drawback for, we could talk about Linux being kind of the cool version of Unix. What's the biggest drawback of using Linux as your home operating system? It does have a GUI now. Less of a standardized GUI, that's fair to say.
Hardware support?
Certainly hardware support, at least specifically higher end hardware support. Linux today has far, far, far more built-in hardware support than it did 15 years ago. 15 years ago, you install Linux, unless you really knew what you were doing or you had worked with this hardware before, you were talking about 4, 5, 6 hours of configuration following install to get a graphic user interface to launch. Because you had to compile in drivers. You had to recompile the kernel for it to support your graphics card and the refresh rate and all this other crap. It wasn't user-friendly. You really felt like you were using your operating system. All aspects of it. Today, it's far, far more friendly. I think if you went out and bought, not buying, you go out and download like Ubuntu Linux, which is arguably one of the more user-friendly ones. You install it, you have a GUI within 15 minutes. In fact, actually, I don't think you have to install it now. You can run it live off a DVD. So you can just test Linux without even touching your hard drive. It just loads it into memory, and then you can kind of see what Linux might be like on your machine. But it works well. Even on laptops. I would say historically, laptops were really the problem for Linux. Because laptops tend to have substantially more proprietary hardware. That's become less so today because they're so mass produced. But we go back 15 years ago, 20 years ago, every laptop kind of had its own little version of, hi, I'm a graphics card. Laptops were not built for gaming. You buy a new laptop today, it has some sort of reasonable recent NVIDIA or ATI graphics chipset in it. Even in what we would consider a weaker laptop, they still play games quite well. So he's sitting back here with an 11.6-inch MacBook Air which actually has a surprisingly powerful graphics card in it. You can play most Mac compatible games on that. It'll get hot. You don't want to have that right on your lap. But even what we consider to be our ultra portable non-power machines can really do a lot today. So today, Linux will actually run well on laptops. In fact, most people probably run it on a laptop. Anybody in here where your only computer is your laptop? Well, most of us have a desktop too.
I never use my desktop.
Yeah, I only use my desktop for gaming, I found.
I don't even use it for that.
Every now and then I'll park in front of it and program while watching Netflix, but I find that I do more watching than coding. But we're really moving in that direction, aren't we? Where everything is really your laptop. At the very least, even if you have a desktop at home, you probably find yourself using it less and less, depending on the types of stuff you use it for, I suppose. But in any case, a big drawback for a Unix or Linux system for hitting the masses was driver support. Wasn't really going to work out of the box for your system. It was really an operating system that was meant to be run without a GUI. The GUI was kind of an afterthought. I would say even today, many Unix system administrators, so many places that have a Unix-based server as their main server or a main server at an enterprise, are still interfacing with it from the command line. They remote into the machine from at home or something like that if there's a problem and do everything from the command line. So from kind of the terminal type thing that we've done here in class a little bit. I would say rarely do they ever launch a GUI. Maybe the only reason they launch a GUI is if their latest, greatest backup product package happens to have a GUI interface and that's easier or something to configure. Most things they'll do from the command line. So that was really a challenge for Unix. But the good thing is the benefit of Unix, it was really geared for a server class setup. So we weren't trying to make end users happy with a nice interface. We were trying to make end users happy by serving them web pages or running other things, streaming video, that kind of stuff. Okay, same thing as before, layered type approach. I remember we talked about microkernels a little bit. So this is the idea of pulling the really core operating system stuff away from the kind of the fluff operating system stuff. So at the center of it, you have the microkernel that is the actual operating system, the heart of the beast, if you will. So when you update the operating system, you really only need to make changes to that microkernel, and everything else continues to speak to that microkernel through the same system calls, the same kernel calls. That becomes beneficial because now you can update the source code. You can update the operating system in patches, if you will, rather than having to have people download, the 8 gigabyte new installer for Windows every single time an update comes out. We like to download the 600 megabyte download, or for a big update, maybe it's a gigabyte, something like that. But we're not downloading the entire operating system again. We're replacing aspects of it. So that's the difference between system space and user space. So user space is going to be less protected in memory from a system perspective. So we might have aspects of the operating system that are not in protected memory. They're running in the user memory space. Communication takes place between user modules using message passing. So this is kind of an example of an inter-process communication. So easier to extend a microkernel, easier to port the operating system to new architectures, more reliable because there's less code, and the microkernel aspect of it's going to be more secure. You could probably argue that there's important aspects of the operating system that get moved outside of the microkernel that might actually be less secure because we're pulling it out of the protected space. So if you think about the microkernel as being what's inside Fort Knox, and then the stuff outside the microkernel that we still consider to be part of the operating system is kind of in the front yard of Fort Knox. And I'm assuming Fort Knox probably has like a big gate beyond that. the other operating system stuff is kind of in the front yard of Fort Knox. So not easy to get to it because you'll probably get shot before you get there, but substantially easier to get to that than get inside where the gold is, right? Isn't that what's in there? There's gold in Fort Knox. Is that the rumor? Wouldn't it be funny if Fort Knox was just a big joke? Like we just keep pointing fingers, like all the good stuff's in Fort Knox. It's actually like in the back room at a Best Buy up the street. Security through obscurity. Well, how did week 1 at Best Buy go? Have you finished training?
Yeah, it was a sales training thing.
So you haven't actually dealt with the real customers yet?
No, I have.
Did you?
iMac yesterday.
Did you? Did you lie to them?
No,
What size iMac?
21.5.
Okay. Why'd you do that?
That was the one they wanted.
You didn't let them know that there's a decent chance that Apple's announcing new iMacs tomorrow?
I thought they were doing iPads.
It is iPads, but there's actually a rumor that they might be announcing the Retina iMacs.
I didn't know about the iPad until yesterday.
This is the crap. This is the crap.
Slang.
Whenever you buy Apple stuff, there's a website out there you can go to. Just do a search for like should I buy a Mac or something, and it gives a list of when the last rendition of that came out and what their recommendation is for the next one and whether or not they think you should buy it now or wait. It's a decent site. I bet you for iMacs they say wait. Yet you just ripped somebody off yesterday. Was it a floor model? Did you sell them a floor model or like out of a real box? I see the thing's probably been sitting at Best Buy for a year and a half. I don't know how you sleep at night.
Yeah, it says don't buy.
See? Maybe you should call those folks up. Like, look, you're going to want to bring that back because I totally screwed you over. Wait, hold on. Are you helping move tonight?
Class.
You got class? Okay, then I'm not sorry for being mean to you. If you're helping move, I'll be mean to you tomorrow. Let's see. So, detriments of a microkernel system is we have performance overhead because now we have an additional layer of communication that has to live between the microkernel, what's inside Fort Knox, and the stuff in the front yard. One more layer of communication. The good news is that level of communication should happen very quickly. So in the realm of how much overhead it is, we're dealing with the fastest aspects of memory for having that communication. But it still is an additional step that needs to be taken. Okay, so for Mac OS X structure, which is based on Unix, we have kind of the user space up here. Then we have the actual Unix kernel environment, and then we have this thing called the Mach kernel. So we almost kind of have two competing operating systems. Mach is kind of an API type thing. BSD is the actual kernel. So it becomes a little bit weird, but I would still call OS X a Unix-based operating system. So, modules. So this gets back to our comment from a little bit ago talking about kind of the evolution of how we program. Not the evolution, well, I guess it's the evolution of programming languages as well, but also our approach to programming, which has driven the evolution of the languages. So most modern operating systems are implemented using more modern programming languages and more modern programming techniques. So we're going to use an object-oriented approach. We're going to separate the core components of the operating system, memory management, process management, those things, into separate objects or separate groups of objects. So that when we have to update one, we're not having to fish through a bunch of code. We can just update that one core piece. Each talks to the others over known interfaces. So the advantage of this is what we can do is we can define the way that memory manager talks to process manager, for instance. And we say, here is the interface that they communicate through. And as long as we keep that interface consistent, so the memory manager is allowed to send these kind of messages to this guy, and process management is allowed to send these kind of messages to this guy. As long as we keep that consistent, that interface, we can make all sorts of changes on either side to improve efficiency, remove bugs, that kind of stuff, without having to worry about there being conflicts between these two guys, because we're always using the same language to communicate. That makes sense? So that's kind of the advantage of going into more modular programming, as opposed to the monolithic main where we change something up here, it might break something down here. Okay? Each is then loadable as needed within the kernel. So this becomes more of a memory management type of feature. So if we have, we could talk about this at the operating system level, I suppose. You have an operating system, and let's say the operating system has 30 big features, of which 7 of them are must-have features. We have to have a running memory manager. We have to have a running CPU manager, those types of things. But we might have a feature set, for instance, let's say a driver. Let's say you have your driver for, a printer. Well, when that printer's not plugged in, that driver doesn't need to be taking up memory space, correct? We have it, it's on the hard drive, but we don't need to load it into memory with all the other crap from the operating system. We could modularly load parts of the operating system into memory as we need them. Kind of make sense? This was also a problem in the early days of Unix, where all the driver support that was ever going to exist in that version of Unix, being more modular than MS-DOS as Unix evolved, but still less modular than our modern day operating systems. All those drivers had to be distributed with Unix day one, and they were all loaded into the into memory so they were prepared to work. How many of you have heard the phrase plug and play? We don't even really say it anymore, right? It's just more of an assumption. If you plug in something through USB, you expect it to just start working. It's not the way it used to work. Before plug and play, when you wanted to plug something into your computer, you would turn your computer off, you would plug it in, then you'd reboot it. So during the boot process, it would pick up on that new device. So you were constantly rebooting your machine. Well, with plug and play, which was the name for it when they first came out with it, you didn't have to do that anymore, at least for many devices. Today, if something says you have to restart your computer to plug a device in, we don't buy that device. That's not something we're willing to do. So our standards have changed. All right, so having a modular operating system allows us to be more specific about which aspects of the operating system we're going to load into memory. Because we want our operating systems to support a wide range of stuff, right? We want it to support a wide range of stuff, yet we only want to load into memory the parts of it that support our stuff. And we really see this in the Android world. A lot of people, if you're comparing iOS devices, so let's say an iPhone versus an Android device, one of the things that people, when they complain or they compare the two, they notice that the iPhones seem to always have less memory. You notice that? iPhones, I think even last year's iPad, had 1 gigabyte of internal memory. Most Android devices have far more than that. Maybe they have 2 or 4 gigabytes of internal memory. Well, why is that? Is that because the iPhone is an inferior hardware product, like the people that are out there saying it's 2-year-old hardware, that kind of crap? Well, it doesn't need as much memory. Apple knows exactly what drivers they need to put in with the software. They only need to support their own crap. Well, Google is solving a harder problem with Android. They're writing a piece of software for a bunch of different people's computers that are going to use different screens, different cameras, different GPS radios, all these other things. So they need to build in support for all that crap. That makes sense? And even to that point, Google only takes that so far. Because what you have is you have some third-party places. Samsung did it for a while. They're under a new system now where I think when Google updates Android, Samsung gets the update day one. They kind of settled on a standard for parts and stuff. But other device manufacturers are still dealing with this problem. Samsung did for a while. And that is Google will release a new version of Android, and then Samsung would have to work on it for a couple of weeks to make it work with their devices. Write new software drivers for their hardware, replace the default search to Bing instead of Google, stuff like that, stupid stuff like that. But, from an operating system perspective, they had to make the default Android operating system work with their actual device. And that becomes an interesting problem. Every single time, the next Android phone comes out, well, really the next any phone, but Android phones come out very often. iPhones come out once a year. So, the next latest, greatest Android phone, that they introduce some new feature in it, whatever that feature is, right? I remember, was it a couple of years ago? I don't think this ever took off, but you had the feature where if you're watching a video and you looked away, it would pause automatically. Kind of know what I'm talking about? That never took off, did it? I don't think. Does anybody have that on their device?
I think it's on here, I just never use it.
So, it's not really functional or whatever. But let's just say, to make that work, they would have had to modify. Android didn't just have that feature built into it. They would have had to extend the Android operating system to support a driver for their front-facing camera to constantly be monitoring your eyes or something, how you're looking at the screen. Well, so, that's why those devices need more memory in them, because we're having to pack more stuff in for special driver support and that kind of stuff. It's not good or bad, it just is a fact of how those operating systems work. That doesn't mean Android's crap. It just means Android's built to run on more systems. Therefore, it needs to have a bigger memory footprint because it needs to support more unique devices. Apple can always have less memory in their machine because they know exactly what devices they're going to support. It's kind of a trade-off. And the only people Apple's competing against is themselves from last year's devices. Right? There's a rumor that the new iPad Air might have 2 gigabytes of RAM in it instead of 1, that they're going to be announcing tomorrow. Well, okay, fine. Well, now they have some new stuff. We probably can go back to the 3rd generation iPad and say Apple's still supporting that heavily. I think iOS 8 runs on the 3rd generation iPad. It might even run on iPad 2. But let's just say 3rd generation iPad. It runs on that forward. Well, what's changed is the 3rd generation iPad. Well, we have the thumbprint thing is going to be in the new iPad. The iPad Air doesn't support it, but we'll have that in this one. We have newer components, newer video, newer speakers, things like that have fit into the continually smaller cases, right? The camera that they put in the 3rd generation iPad is not the same camera that they put into the iPad Air last year. Even if it's the same megapixels and stuff, it's not the same physical piece of hardware. Because that wouldn't have physically fit in these new, thinner devices, right? You go back to the original iPhone, it was substantially thicker than the iPhones today. So an 8 megapixel camera isn't necessarily an 8 megapixel camera. They're physically different pieces of electronics. So Apple has to keep up only with themselves. Where on the Android side, we can have innovation on a month-by-month basis as the next device manufacturer comes out with their newest device and tries to one-up the other people that are out there. So in the Android market, it's much more like the competition between NVIDIA and ATI for graphics cards, where every single time a new graphics card comes out, there's some feature that one-up the previous guy, right? There's more cores in this, or more memory, or this guy has more shaders, whatever it is. There's some feature where they just keep one-upping the other guy. So it becomes kind of an interesting thing. So there's things like that we have to take into consideration for the hardware that's going to be running software. Things aren't always as they seem. All right, Solaris was a version of Unix. Anybody know who made Solaris? Yep, Sun Microsystems, now called Oracle. But Solaris was their Unix operating system. Prior to Solaris, it was called Sun OS, which was also a Unix-based operating system. Then they called it Solaris, which sounds cooler, right? Solaris sounds legit. And the Sun machines ran on a processor called Spark chips, which is a reduced instruction set processor, similar to what PowerPCs, in terms of, Macs used to run on PowerPCs, which were a reduced instruction set as well. And the Macintosh lovers used to say, oh, Intel's garbage, blah, blah, blah. And PowerPCs where the real awesomeness is. You had when the G4, the PowerPC G4 processor came out with AltiVec. AltaVec was like the ultimate multi-threading. They used to have the commercial for 2 heads are better than 1, and then you realize the operating system only supported 1 processor at a time. Kind of, but yeah, I'm sure Evan could have still sold that Mac. So yeah, so you had all the Macintosh fanboys talking about how awesome PowerPC is. How many of you have seen any computers for sale lately with PowerPC chips in them? No. Yeah, there was actually probably one of Apple's greatest decisions in its history was moving to the Intel platform for their processors. It gave them a lot of flexibility with their machines, and also made them far more compatible. Gave a bigger reason for buying a Mac. You know, how many of you specifically bought a Mac because you can run Windows and the Mac OS on it? Certainly a reasonable argument for a technology person. That's the argument I give computer science students when their parents come and visit. You know, it's not that, hey, buy a Mac because they're better. It's the same crap. These all have the same hardware in them, right? So Macs are made of metal. Fine. Is that really worth paying twice the price? No, because it dents instead of cracks. Right. You know, it's you could buy a Ferrari, you could buy a Chevy. They're both going to get you to work. Ferrari will probably get you pulled over, actually. So, but in any case, you know, the argument I make to the parents is a Mac gets you 2 machines for the price of 1.6 or 1.7, you know, whatever the math is. So that's good for a technology major. But in any case, Solaris was a proprietary Unix operating system made by Sun Microsystems. So by proprietary, this was almost solving a similar problem to the Apple problem. So this was a Unix operating system that was built to be a server class operating system. Later on, it was kind of, we can say, server or workstation class operating system. Workstation being, you know, I'm a graphic engineer or a software engineer writing software for servers, so I might be working on this. Or CAD design, computer-aided drawing type stuff, maybe would have run on this as well. But in any case, the operating system Solaris had the benefit over generic Unix operating systems because it was designed to run on Sun's own hardware. Sun was very much like Apple from a hardware-software perspective. They wrote their software and they also made their hardware. So Solaris had to run well on their own crap. That makes sense? So that made Solaris actually a very popular Unix-based operating system for enterprise. The school I used to teach at, Western Illinois University, was a Sun shop. So I was a Unix sysadmin there while I was teaching, and you know we had all Sun computers. And you think Apple is expensive? Yeah, Sun hardware. I don't even think Sun makes hardware anymore. I'm not positive, but I don't think they do. It's possible they do, but whatever. But they used to be a big hardware manufacturer and expensive, really expensive. It would make Macs look like, you know, the banquet TV dinners. So kind of an interesting thing, but Solaris was solving a similar problem to Apple where they were writing software to run well on their own hardware, which made Solaris maybe a little bit more stable. Operating system had less bloat. As our more modern operating systems started coming out, where they became more and more modular and less crap had to be loaded into memory, that idea of bloating became less of a problem. The only thing that would be bloated was our hard drives with this driver support sitting on the hard drive. But we roll back to that point in time, and really that was still a problem. Our hard drives weren't that big because this is still living in the realm where disk storage was expensive. All these things are out the window today, right? We don't really care if the install base of our operating system today is 8 gigabytes or 12 gigabytes. We don't notice, right? We don't care. It's like, I got a 3 terabyte hard drive in my machine. How much free space do you have? Plenty. That's the official answer. It's plenty. Okay, most of you only know how much hard drive space you have free if you download a lot of like movies and audio and stuff like that, because that's something you're constantly dealing with, right? How much you're filling up your hard drive. For most of us, if you're installing application programs and saving your homework and crap like that, you might as well treat it as an unlimited bucket. I run into the problem in here a little bit. This laptop has a 256 gigabyte solid state drive. So by our modern standards, 256 isn't that big of a hard drive. It's a really cool hard drive, a really fast hard drive, but I do have to be careful when I deal with, every single time I, when I record lectures, they all go into this folder. So about once a week, I have to delete them. Every lecture I record is 600 megabytes, 500 megabytes, blah, blah, blah. Here's a 2.19 gigabyte file. I recorded a little bit higher capture rate. This was something I made for YouTube. But, in any case, this adds up. And if I have a 256 gigabyte hard drive, a couple weeks of classes, and I got that thing kind of starting to fill up. So things to consider even back then is we didn't have this idea of unlimited storage. So the less bloat we can have in memory as well as the hard drive, the better. And that's kind of why a company like Sun Microsystems did so well with Solaris in that time period. They've really died off since then because there were so many other options. As memory and hard drives became less and less expensive and became larger in size, we cared less about optimization and we really care a lot more about flexibility. We wouldn't buy a computer. You wouldn't have built your gaming computer if you didn't know that it was going to be future-proof to a point where you could put a graphics card in 8 months and it would work, right? That's not advantageous to you as a gamer. You spend a lot in your graphics card day one, so you're going to be resistant to just pull it out and sell it. But if at some point something else comes out that you really think you want, you know it'll work in your machine. That wouldn't have been the case historically. So the Modular Pro Solaris used, we had the core Solaris kernel. So this, we can call this the microkernel, if you will. Then we had all these individual pieces hanging off of it. So the scheduling classes for CPU scheduling, file system, loadable system calls. So these would be actually that second layer of system calls. Executable formats, it's kind of unrelated to our modern stuff. This is unrelated as well. Miscellaneous is just a catch-all. Device and bus drivers. Really, this idea of drivers is a much more modern concept in operating systems than we might believe. Drivers are fairly recent. Even back in the Solaris days, drivers didn't mean what they mean today. Those drivers were mostly written by Sun Microsystems. Apple writes all their own drivers as well. That's why a lot of times you don't get support for all the various hardware pieces to work on the Mac. This is why people who get a Mac Pro that is upgradable from a hardware perspective can't necessarily always use the latest, greatest graphics cards. If Apple doesn't know about it and Apple doesn't want to support it, it's not going to work. That becomes problematic. So, in any case, Solaris broke their operating system into a bunch of individual objects. These are modules, so we're looking at it as being kind of a object-oriented approach, but this is really preceding object-oriented programming languages, or at least being in the very early days of object-oriented programming languages. So we kind of see the chicken or the egg problem here with which drove which. Did the object-oriented language drive this more modular support, or did the concept of modular programming really drive the need for more object-oriented languages? Kind of an interesting thing to consider. Okay, concept of a virtual machine. So let's just talk about this for a minute with the last minute in class here, and then we'll pick up here next time. But so what do you know about virtual machines? What do we use them for? What's the purpose of a virtual machine? Over the last five years or so, these have become really popular, right? The concept of a virtual machine. A virtual machine is a computer written in software that shares some of your system resources. So you have an operating system running inside of an operating system. That's a virtual machine. So we might use it for a lot of different things, but one advantage we have is from a security perspective. If you have a virtual machine and the virtual machine gets a virus, you really haven't damaged your actual underlying operating system. So we'll talk more about virtual machines next time and kind of the different ways virtual machines are being used today, including entire businesses built around virtualizing. Okay, we'll pick up there on Monday. Friday we have our midterm. Capiche? Okay, and again, if you're helping move, 4:30 by the Circle Drive. Bring your arms and bring your appetite.
Can we bring